Are we live yet?
We're about to be live, yes.
Am I allowed to? Can you show them my little station?
No, that won't really work.
But can I at least say hi, I'm a teacher?
Hello, everybody. Mr. Cornell here, COVID teacher, and this is my assistant, Jolie. Hope everybody's staying safe. Hope everybody is staying quarantined away from people so that they do not spread it even more. And what
I'm
we
the
are
assistant
going to
teacher.
do. Good evening, Tiffany. Hi, Hannah.
Hi.
Tiffany's there. Hannah's there. Got a couple people. No, that's one of Daddy's students.
Hi, Hannah.
They're gonna say hi, but it takes a second. She said happy birthday. They remembered it was your birthday.
Thank you, Hannah.
And then in 4 more days, it's Noelle's birthday. I just came back from Walmart. That sounds terrible, Tiffany. Okay. So, what we are going to do here, Tiffany said happy birthday too, is we are going to go over whatever questions you want to do from watching the video. I'm not going to go through the whole entire thing. I'll kind of touch upon a couple of things, and then we'll go through the homework, and then we'll see if anybody has anything else. All right, so what we have here is probability. It starts pretty basic, nothing really too crazy. Probably some things that you've seen before or done before, and now we're just gonna kind of continue to go from there. So if you watch the video, he went over these probabilities and he went over some of the terms. So like an experiment would be just whatever it is that you're going to be testing. The outcome is, well, what you want to get or what you are getting. And then you have your event, which would be a collection of one or more outcomes, basically what you're getting, and then your sample space is the total, all of the different things that you can get. Okay, so then he went through some of these examples and went over just kind of how they could write it as a formula. You don't really need to know that part of the formula, because as we kind of touch upon how we set up the fraction, you'll kind of get that idea. But basically what they're showing here is that the NE is they're showing basically that would be what you were trying to get, or how many different ways you can get that, where you're, and then down here is the total. So remember always in fractions that your denominator is going to be your total. Okay. He touched upon theoretical and empirical probabilities. So basically the way that works is if you're theoretical, okay, those are the events that are going to happen. That's the probability. It's not going to change. So perfect example is flipping the coin. So you can either get heads or tails. So if I wanted to know the probability of getting heads, you have a 1 out of 2 chance of getting the heads, because that's the only way that could happen. Empirical is what we're living right now. Say the COVID-19. They say that 1 in 6 people could get the virus. Does that mean if I put 6 people in the room, one of them has to have it? No, they don't have to, but odds are in the favor that one of them will. So that's kind of the way those two things work. Where theoretical, if I wanted to know what's the probability of getting a heads, it's a 1 in 2 chance. That's always the way it's going to happen. Okay, we're going to, here's some tree diagrams. So from this page here, looking at this place with the heads and tails, did anybody have any questions with that up there? There's a delay, so I have to wait and see. If somebody writes no, I can just keep going. Waiting to see if anybody writes no.
Why?
Well, I have to see if anybody has any questions.
Happy birthday, Mr. Cornell's daughter. Thank you.
Oh, now they're all going to start typing. And then what you have here is that empirical probability, whereas just kind of what we were talking about. So they kind of, stop, get out of here. They kind of took a look at it and they were saying, okay, these are how many people out of the total 53 people that they asked or maybe that they surveyed to try to get these answers. Okay. Okay, here were some practice questions that he had there. And I think that was the end of it. Okay, so that was the end of it. So what I'm going to do now is I'm going to go ahead and I'm going to go over the homework with you guys. So if you started it, you could check it. And if you did not, then we're just going to kind of do it now. All right, so here we go. He didn't do those questions. Oh, thank you, Hannah. All right, so we'll go back. What homework? There's the packet that says homework on it. So your job, Tiffany, is to watch the videos, and then my job is to go over these homework questions with you, okay? So let's start with these homework questions and see how much of what you watched you understood. Okay, so question 1. Which of the following could not be a value of probability? Okay, so remember as they're explaining, probability goes between 0 and 1, where 0, it'll never happen, 1, it will always happen. You won't go above or below that. So 53%, you can have that, that's almost half. 78%, 3/4, which would be 0.75. Okay, we'll do all that empirical stuff. It's really, don't really worry about the difference between the theoretical and the empirical. You'll just kind of see the difference as we go over it. Now, if you divide 5 divided by 4, that's going to be a decimal of a number over 1. So that's why you're not going to have that probability. Okay, next one. If a month is picked at random, which of the following represents the probability its name will begin with the letter J? Okay, so remember, we're writing probability as fractions, okay? So what you want goes on the top, and your total number of outcomes that you could have would go on the bottom. So down here would be 12 because there are 12 months. Now, what months have the letter J? That would be January, and that would be July. So how many is that?
June. And June.
Oh, we forgot June. Thank you, Assistant Jolie. So that's June. So that's 3 months out of the total of 12, which simplifies to 1 over 4. Or you, again, throw it in your calculator, 3 divided by 4, and that's going to be 0.25. Okay, so all of the questions that we're going to be looking at today, that's how you do it. That's how you're setting it up. Okay. So if a coin is tossed twice, which of the following gives the probability that it will land both times heads up or both times tails up? So let's look at all of the ways. And this is where the tree diagram or sample space comes into play. Now, I like the tree diagram the best. All right, so if you look at it, we start. So they said that we are going to flip it 2 times, okay? So the first time I flip it, what could I get? I could get a heads or I could get a tails. Now I'm going to flip it a second time. So if I got a heads on the first one, well, then I can get a heads again, or I can get a tails. Or I can get a heads here and a tails there. So this now shows you all of your outcomes. So there are 1, 2, 3, 4 different outcomes that you could get. So if you're creating your fraction, the 4 goes on the bottom. Now what did they want? They wanted you to have heads up twice. So that happened 1 time. And then you wanted to have 2 tails in a row. That happened 1 time. So you have 2 possibilities. And then that simplifies to 1/2 or 0.5. Okay. Tree diagrams are my favorite because you can kind of see everything and there's no, did I get that one? Did I miss that one? When you have to maybe write out the sample space, which is what they're going to try and have us do in number 4 here. So here we go. A spinner is now created with 4 equal size sectors as shown. So there it is. An experiment is run where the spinner is spun twice and the outcome is recorded each time. So they're going to spin it, write the number they get, spin it again, write the number that they get again. So what they want us to do is create a sample space list of ordered pairs that represent the outcomes, and here's an example. So if they spun it the first time, they would have gotten a 4. And then they're going to spin it a second time, and then they're going to have a 2, and then they wrote it as 4, 2. So now they're not really asking you to write it as a tree diagram, although you can, but they're asking you to write it as a sample space as ordered pairs. So as here, the first number represents what you can get on the first spin. So I could get a 1, and then if I spin it again, I can get another 1. I could spin it and get a 1, and then I can get a 2. I can get a 1, and I can get a 3. I can get a 1, and then I can get a 4. You can get a 2 with a 1. You can get a 2 with a 2. You can get a 2 with a 3. You can get a 2 with a 4. You can get first spin 3, second spin 1. And then remember, that would be different than getting a 1, 3. 3, then 2. And then 3, 3. And then 3, 4. So this, nope, I forgot 4. Ignore. 4, 1. 4, 2. I can get a 4, then a 3. I can get a 4, and then a 4. Okay, you could also write that as a tree diagram, but that would get a little bit messy. And that one's pretty straightforward. So that would be listing all possible outcomes that you can get from spinning the spinner twice. Part B says, using your answer from A, determine the probability of obtaining 2 numbers with a sum of 4. Okay, so if I'm going to do that, then I'm going to find the probability. So the bottom number is going to have my total. So how many different outcomes did I have? Well, I listed 16. So there's my 16. Now go through each one, and I will figure out which one has a sum of 4. 2, okay, here's 1. Okay, 2 plus 2 is equal to 4. 3 plus 1 is equal to 4. And it looks like that is it. So then I would write that as 3 over 16. And that would be my probability. And if they asked you to round it or write it as 8%, you could put it into your calculator, divide your 2 numbers. All right, so now let's do some non-multiple choice questions asking us to kind of do that again. So Samuel pulls 2 coins out of his pocket randomly without replacement. If his pocket contains 1 nickel, 1 dime, 1 quarter, what is the probability that he pulls more than 20 cents out of his pocket? Justify your work by creating a tree diagram or sample space. So here, where they're asking you to show the work, and you can either do it like this, or you can do it like this. Okay? Either one's fine. Personally, I feel like when you're listing the sample space, you kind of have to think about it, make sure you didn't miss anybody, where the tree diagram, you just kind of roll through it. So here's how that would work. So he puts 2 coins in pulls 2 coins out of his pocket. So remember, he has 3 possible things that he can do. Okay. So let's do it here. So one of it is 5 cents. Then the other one, God bless you, is 10 cents. And then you have 25 cents. Okay. So this would be the first pull out of his pocket. So he can get any one of those 3 things. Now, when he goes in again, what could he get? So now question number 1, can he get another nickel? Can he get another nickel? Well, it said pulls 2 coins out of his pocket randomly without replacement. So right there, without replacement, tells you you're going to pull it out and you're not going to put it back. So if you just pulled out a nickel out of your pocket, that means there's not a nickel there anymore. All you have left in your pocket is a dime and a quarter. So that's it. That's all you can get. Let's say you pulled a dime. If you pull the dime, what's left in your pocket? there's a nickel, there's a quarter. Let's say you pulled the quarter. What can you get? You can get a nickel or you can get a dime. Okay? All right, so now let's answer the question. What is the probability that when you pull out those two coins, you get pull more than 20 cents out of your pocket? Well, 1, 2, 3, 4, 5, 6. I have 6 total outcomes. If I pulled a nickel and a dime, not more than 20 cents. A nickel and a quarter, yes. A nickel and a dime and a nickel, no. A dime and a quarter, yes. A quarter, yes. Yes. So 1, 2, 3, 4. So that would be a 4 out of 6. That simplifies to 2/3. Okay. God bless you.
Thank you.
Now, that is fine. What you could do from here, or what they could ask you, it could be multiple choice. It could be written as a percent. You could just put it in your calculator. Okay, they're gonna always have it to the nearest hundredth. So you could say it's a 67% chance that when you pull the two coins out, that's what you get. Okay, so that right there, that's your answer. That's how you show your work. That's everything you would need to know to answer that question. Okay. All right, 6. Okay, it's almost the same exact question. Okay, Janice, Tom, John, and Tamara are trying to decide on who will make dinner and who will wash the dishes after. They randomly pull 2 names out of a hat to decide where the first name drawn will make dinner and the second will do the dishes. So, determine the probability that the 2 people pulled will have the first names beginning with the same letter. Assume the same person cannot be picked for both. So Janice cannot make dinner and do the dishes. Okay, so you have Janice, Tom, John, Tamara. Okay, Janice, John, Tom. Yep, Tom and Tamara. Right. So, what do we do first? First, we make dinner. Who can make dinner? Janice can make dinner. John can make dinner. Tom can make dinner. Tamara can make dinner. Doesn't matter what order you put these in. All right. After we make dinner, what are we going to do? We're going to do the dishes. Okay, so who can wash the dishes now? If Janice made dinner, she doesn't have to wash the dishes. So we're going to say John can. We could say Tom can do the dishes and Tamara could do the dishes. If John does it, then Janice could do here. Tom, Tamara. Then if Tom makes dinner, it could be Janice, John, or Tamara. Or if Tamara makes it, then it could be Janice, John, or Tom. So right here, what you have all of the possibilities. So if you're going to write this as a probability, we'll set up our fraction. 3, 6, 9, 12. 12 total possibilities. Now, they said when you pull it out, what do they want to know? Okay, the first 2 letters are going to be the same. So there's one choice. There is another. There is another. And there is another. So there's 4 different ways that you could pull someone to do the dinner, someone to do the dishes, and the first letter of the first name will be the same. Okay, and again, that would simplify to 1/3. Could give you like that as a choice if it was multiple choice, or you can do 1 divided by 3, which is 0.333, so that would just be like 33%. Okay, so there you go. That's how you're going to answer that question. And then our last one is, okay, so again, if you want to get crazy with theoretical and empirical, these are theoretical. Okay, those are your choices. Those are the only choices that can always happen. Here is when you start getting into empirical, where they're just kind of taking, I guess, the odds game of what you could get, okay? So a blood collection agency tests 50 blood samples to see what type they are. Okay, so here are your 50. Their results are shown in the table below. So if a blood sample is picked at random, what is the probability it will be type B? So this is what you want, and then over your total. So how many people had type B? 7. How many people are there? 50. There's your answer. Okay, and you're done with that one. Same thing. If you're type O, well, there are 18 people with type O, 50 people in total, 18 over 50 if you're writing it again, so you have a 9 over 25 chance probability of getting that, okay? So it's the choices over the possibilities. So the question is, these are choices, these are your possibilities. Yes, so the bottom number is always your total possibilities. Your top number are always, I don't want to say choices, but the number of that possibility, okay? The number of that possibility. So the number of O's in this sample was 18. In A, the number of B's was 7, okay? Here it was kind of the same thing, okay? What did they want? Okay, I see what you're saying. What are their choices, okay, to get that, what they specifically want, okay? And then we just talked about why this is empirical, because that's just, it's kind of like an odds game of what you could have based on a survey, okay? Again, like what we're living right now. They say 1 in 6 could get the coronavirus. Does that mean if I throw 6 people in a room, one person must have it? No. That does not mean one person must have it. If you were playing this game and your odds are 1 in 3, is that going to happen? Yes, because one of these is definitely going to happen because those are your only outcomes. Okay. So with that being said, does anybody have any questions before we finish with the lesson? Yes, I am done because next is 12.2, which is sets and probabilities. So again, what you would do is you would go online, you would watch the video for 12.2. I'll explain, go over any questions that you might have for 12.2. Then again, I'll go over the homework, and then that'll be it. So it'll be quick. Okay. Nate's always confused, and Nate was late again. It's kind of the way it goes. Hi, Brenna. All right, so the video will stay up. So if you have any more questions on it, you could always go back and replay it and watch it again. If you have any further questions, remember you can always send me a video and remind. Can you explain the difference between the theoretical and the empirical? So yeah, again, so take a coin, right? Okay, so take a coin. So a coin has a heads and a tails. That's it. Okay, you have no other possibilities. So if I wanted to know what was the probability that I got a heads, that's how it could be written. Okay, so we're going to go over that pretty soon. So if you see PH or kind of say PT, okay, this saying, what is the probability that you're a heads? What is the probability that you're a tails? Well, remember it's a fraction. Okay, what do you want? I want a heads, so you can have, there's one heads on it. And then how many outcomes are there? There are 2. Okay, and the tails is the same thing. How many tails? That's 1, then that's a 2. So this right here, this is theoretical, okay? Theoretical is if you're playing, say, this game, this is happening, okay? It's not happening, okay? 100%. Whereas if you go into empirical, okay, it's more of a, okay, here is a survey that was done, okay? Let's say like this one here. Here was a survey that was done of 50 people. And then this is what they found. They said they found 18 people had this, 22 people had this, 7 people had this, 3 people did this. And they want to know, well, what is the probability of you getting that? Well, here is your probabilities. Now, if they did the same exact thing tomorrow and pulled out 50 samples, are they going to pull out, again, exactly 18? Are they going to pull out exactly 22? No, they're not going to pull out exactly 18 or exactly 22, but it's going to kind of be around that probability of around 7 out of 50 or something like that. Yes, so as Ms. Holden, empirical is going to be an experiment or a survey. Okay, so that is going to be the difference between the two. So yes, so tonight you're going to do 12-2, and then tomorrow again we'll go live and we'll go over the homework for that. So I'll tell you to do 2 things. One, if you're new to this or you don't have this, remember you can go to www.cimath.com and you can download and print out all of the work that we are doing here. There is a link that will take you to emathinstruction.com where this does come from, and there is the explanation to all of the lessons. So what we're trying to do is have you watch those lessons, and then I'll answer any more questions you have from the lessons, and then we'll go over the homework. Ms. Holden says I posted the answers for 12-1's classwork and homework on the website. So again, if you want to go back and have further, if you want to look at it anymore, you can look at it there. If you want to remember, you can always go send me a remind and kind of tell me when's the best time. So we only have about 13 people here, so there are quite a few people missing. So let your friends know. If any of your friends are in Algebra 2 Trig, let them know that we're doing this. Who knows how long we're going to be here for. And if you have no more questions, then yes, we will definitely be done because I have gone through all of the homework. All right, so thanks for listening. Leave a like, hit the subscribe button if you haven't, and